All right, ladies and gentlemen, we're looking at the second differences of your Station 2, which all had negative integers. So let's talk about this first. We've got 0.04, 0.0625. These are your y values. 0.1111 repeating. 0.25, 1 undefined. 1.25, 0.111 repeating, 0.0625, and 0.04. Now we've got to find the differences, so let's do this together. We've got 0.04 minus 0.0625, and from here to here is negative 0.0225. Okay, then we've got 0.0625 minus 0.111 repeating. And we've got approximately, this is not 100% accurate, 0.0486. Okay? 0.111 repeating minus 0.25 gives us negative 0.139. 0.25 minus 1. Oh, excuse me, 1 minus 0.25 gives us 0.75. I'm sorry, these are all positive. I did that wrong. They're all positive. 1 to undefined, we can't do. Undefined to 1, we can't do. 1 to 0.25 is negative 0.75. This is 0.0139. Minus, this is negative 0.486. Oops, 0.486. And this is 0.0225 negative. Okay, well it's got a little 2 up there even though it's negative, so let's see if the second differences work. So let's go between these two. 0.0486 minus 0.0225. We get 0.20231. Between these two, so 0.139 minus 0.0486, we get, they're not the same. What do you think that means? What do we think? Do we think we're able to find the second differences and that's going to give us A like the last one did? No. I can tell you right now, the differences don't work for this page. They don't work. You can't do the second and third differences and be able to find A, and that's because they're to a negative power. One thing I want to talk about before we move on to this page to answer the question. If I want to, can I have a negative power? We talked about this. You can't have a negative power, so how do you get rid of a negative power? What do we do to it? We talked about this back in January, yes. If it's we flip it, so we put it on the bottom. So it's the same as 1 over x squared. Those two things are the same. So let me ask you a question. Why do you think it's undefined for 0? Okay, what's 1 over 0? Can we divide anything by 0? Is that allowed? No. That's why 0 is always undefined. That's why 0 is always undefined. Let's go ahead and answer our questions on the next page. Let's go ahead and answer our questions on the next page. Okay. So how did the graphs compare to each other? All were undefined at 0. The general form of a power function can be written as f of x equals a to the x to p, where a and p are constant. What effect does the value p have on the graph? Well, we know if p is even, it's symmetric. What if p is odd? symmetrically reflected. We'll call it that. Symmetrically reflected. Okay. What effect does A have on the graph? We've talked about this before. Yes. How wide and skinny. What else? There's one more thing. Yep, if positive or negative. If it's positive up or negative down. Good. Okay. Where did the A show up in our tables? So if we were to look at our tables, where did A always show up? Yes. When X was 1. When X equals 1. And that makes sense because, right, if you multiply something by 1, it's going to be 1. Did the difference in the table seem to be related to the constant equation for this one? No, it did not. The differences didn't help us at all. Okay, so let's talk about between station 1 and station 2, what things you noticed were different. The powers were negative for station 2 versus station 1. If we were to go through these questions, there's some differences. Well, they all crossed at 0, and this one, nothing happened at 0, so that's a little bit different. The p-value did the same thing, right? If they were positive or negative, made it symmetric or made it reflective symmetric. A value did the same, whether it was positive or negative powers. The A value always showed up when X was 1, if it's positive or negative powers. But the biggest difference between station 1 and station 2, right here, is the differences, if they were positive, showed I could find the A value from them. If they were negative, it didn't do me any good. So we're going to do station 3, which is powers to a fraction, and we're going to see if they make a difference. Okay? All right, Miss Parmalee, would you start passing out station 3?
Yeah.
And 3?
Yeah.